Okay, today is the last day we get to work on the packet, Squirrel. And then we get to start playing Monopoly. Are you ready to play Monopoly, Squirrel? She's very against Monopoly. It's going to be rough. I'm going to try and get her to roll the dice, though, because I think that would be hilarious. Right, moving on to what we did last time. So we did 7, 8, 9, and 10. Remember, we talked about the minimum value occurs when X is a certain number is a different question than what is the minimum value. We're on to number 11. Number 11, we have this beautiful equation, plus 80, that represents the height of an object. I've graphed it on my calculator. Determine the number of seconds it will take to achieve its maximum height. So we need to find the maximum. Menu, analyze graph, maximum. We found the maximum is at 2, 144. Now, if you put this down, you're wrong. It's asking for the number of seconds. It only wants the time here. So it wants 2 seconds. If it asked how high is the maximum height, then it would be looking for 144 feet or whatever. But in this case, it's asking what is the number of seconds. So make sure that you are looking at the X value only there. Okay, state the time interval in seconds during which the height of the object is decreasing. Okay, so height decreases. To decrease means to go down, right, Squirrel? Yes. To decrease means to go down. Feet do not belong on the touch screen, Squirrel. Decrease means to go down. So it's starting, if we start at t equals 0, we're starting up here. And then what does it do? Does it start going down? What does it do, Squirrely? It starts going up. So it goes all the way up until it hits 2 seconds at a maximum of 144 feet. And then it starts falling down until it gets to 5. So the time that it is decreasing would be from 2 seconds to 5 seconds. All right, and that is how we do number 11. To do number 12, what you'd have to do is you'd have to go through and you'd have to graph all of these and figure out which one is less than the minimum shown. So the minimum that's shown, let's zoom into that guy, is 3, 2, 4, 6, 7, -7. So you want to figure out which A, B, C, or D, which of those graphs has a minimum that's lower than -7. So you're going to graph them, figure out which one goes lower than -7. I'm not going to do that one because that's just a lot of typing in the calculator, which I think you can handle. Next one I want to go to is 14, which is pretty much the exact same thing. We've got an A, we've got a B, we've got a C, and we've got a D, and it's asking which one has the largest maximum. So this one is going all the way up to 2.5, comma, 2, 3, 4.5. So this one goes up to 4.5. That's the biggest it goes. This one looks like the biggest it goes is a little bit over 9. Over 9. So just a little bit over 9. So probably 9.5. So we'll call that 9.5. And it hits that at 1.5. And then you're going to type in these two and figure out if they hit higher than, well, we know it's not D, than the 9.5 that C is. So you're going to figure out which one hits the highest maximum. All right, let's go to 13. For 13, we're going to clear the graph again. And we're going to do x squared minus 4x minus 1, and you're going to graph that. And that's unfortunate. That's not what I wanted to do. What just happened there? All right, there we go. Menu 263. And we could graph that sucker just the way that he's shown on the graph, which means it goes there. And then at 1, it's down 4. And then there. So it looks sort of like this. On the set of axis below, draw the graph. And then we have to actually write it. Make sure you go all the way to the end. Make sure you have your arrows. Make sure you have your label. That's just good math. State the equation for the axis of symmetry. So we need to figure out this axis of symmetry right here. Yeah, we've done a lot since axis of symmetry. Axis of symmetry is a mirror squirrel. So it's a mirror. We need to figure out where it looks the same on both sides. And it looks the same on both sides there. And that mirror is going to be x equals 2. That's our answer. Where x equals 2, that is going to be our mirror. All right, now that we have done those, I want to go on to number 15. Now, number 15 should look vaguely familiar. That's because it was an option to do on the midterm. On the midterm, I wanted to see if you guys could handle something like this. I gave you another one, which some of you chose to do, but personally, this one is one of my favorite ones. So we're going to type this one in, 1 over 225 x squared, and then plus 2/3 x. Type that in, hit enter, and we've got something that looks like this. Now, this is a football player attempting to kick a football over a goalpost. Well, when we're trying to kick a ball somewhere, it goes up and then it must come back down. And if we take a look here, it says graph on the overall from 0 to 150. X needs to go from 0 to 150. Well, my X is going from -10 to 10. So I'm going to go like to 160 so I know what's happening here. Whoa, okay. So now I see both sides of it, but I'm clearly not tall enough. So let's make that taller. Let's go up to 50 maybe? There we go. That's beautiful. Love that. Okay. So now we can go dissect the problem. Player attempts to kick a football over a goalpost. The path of the football can be modeled by this function. So that's the function that I typed into the calculator. So we typed that guy right on into the calculator. Where x is the horizontal distance from the kick, h is the height of the football above the ground. Both are measured in feet. On the set of axes below, graph the function over the interval from 0 to 150. And we want to determine the vertex and interpret the meaning of the vertex. Okay. Now, I am not going to draw a very pretty picture. If this were a Regents, or in your case, the midterm, you should definitely have drawn a very pretty picture. But I don't have time for that. And you don't have time for that right now. We're going to find the maximum, and the maximum is at 75, 25. Okay. So the vertex is at 75, 25. Interpret the meaning in the context. Okay. So x is what? X is the horizontal distance from the kick. Okay, so 75 feet away from the kicker. It reaches 25 feet in the air. It hits a max height of 25 feet in the air. So that is what the X and the Y mean. The goalpost is 10 feet high and 45 yards. 45 yards? Come on now. What is 45 yards? Well, you'd either have to go look at your conversion sheet or you'd have to know that there are 3 feet in a yard. So 3 feet for each 1 yard means 45 times 3. So we go, yeah, 45 times 3. Got to use our scratch pad. And we get 135. Okay, so that's at 135. So if we go over here to 135-ish, will we want it over 10 feet? It's okay if it's over 10 feet. No, if it's under 10 feet, then he doesn't get a score. Okay, so we've got to go 135 feet. So we're going to go escape this, go back here, and we're going to figure out what it is at 135. In order to do that, all right, what we're going to do is we're going to go to Menu, Trace, and we're going to trace this graph. Okay, it starts at 110 and we're at 19.6. We need to go all the way to 130. Oh, okay. 130 bounces to 140. So what we need to do, Menu, Trace, and I want the trace step to be 5. Enter. Okay. That way I can bounce up to 135, and the highest it is at 135 is exactly 9 feet in the air, which is not enough. No, he needs to be 10 feet, I told you. This isn't soccer. We're not trying to get it in the goal. We're trying to get it above the goal. Yes, that does require knowledge of football. I'm surprised I know that too. But yeah, the football goal looks like this. You got to get it up and over the goal. Not like a soccer goal, which is like this, where you got to get it in the goal. So in football, we need to get it over the goal. And it only hits 9 feet when it's 135 feet away. So it is not going to reach the goal. It's not going to pass over the goalpost. No, it's not. It's not going to pass over the goalpost. You've got to trust your calculator, squirrel. And by justifying our answer, we can just say this. 135, 9 means 9 is less than 10. Yes? Yes, even squirrel agrees on that. All right, and that ends your packet. Try and do as much of the problems as you can, as many of the problems as you can. If you need help with some of them, be sure to message me and I can help you out, or you can email me. Regardless, by Monday, that would be April 27th. Yeah, April 27th. That's when I extended the due date to. By April 27th, you need to hand it in. And do you remember how I told them to hand it in, Squirrel? Do you remember? No? Well, they have to make a movie. Yeah. They have to make a movie to show me their pets or their siblings or their pet penguins or something like that. They have to make a movie, and then during the movie at some point, they need to show me their packet. Yep, that's what they need to do. And they're going to message me it. Yeah, they can turn that in on Edmodo. Can you believe that? It's crazy. All right. Thank you very much for tuning in to this episode of Izzo Teaches Squirrel Algebra. Once again, if you have any questions, please feel free to message me, and make sure that your homework is videotaped or videoed on your phone and then sent to me on Edmodo Messenger. Thank you very much. Have a wonderful day.